Yo, it is late tonight. I gotta go to bed very soon. I was working on some more of my internship project today. And I had a meeting with some, some students as well. At like 8:30, and then I had to kind of fix up a document, post it. So that's why we're starting this video late, 10:54 p.m. Yeah, I'm gonna see if I can just speed through this video. Probably make it really fast because I gotta actually push some code out and then go to bed because I got work in the morning. So let's go ahead and let's just maybe just do one problem today. Feels like a cop out. Apologies about that, but you know, it's a little late. It's a little late. So this is supposed to be an easy one. A lot of times these easy is just like you can BS it, but like I kind of want to get down to the core principle of like what we're doing. You know, I don't want to just BS it just because. Okay. So you are given a large integer represented as an integer array. Sorry, you're given a large integer represented as an integer array of digits. Okay, I see. Where each digit I is the ith digit of the integer. Okay. The digits are ordered from the most significant to the least significant in left to right order. The large integer does not contain any leading zeros. Increment the large integer by 1 and return the resulting array of digits. Oh, right. So it seems pretty easy at first, but then you have to remember that you're going to have to kind of go recursively back through it. Yeah, in case things happen. Let's see, sorry, I have to answer a text real quick. Okay, so we're just going to carry over the bit to get, if you reach the end, then just adds 1. Pretty much simple as is. So, I'm going to call this carryover equals 0. And then index equals length of digits minus 1. While index is greater than or equal to 0 and carryover is equal to 1, here's what we'll do. We'll say we use modular for this instance, I think, right? I always mess this up. I'm gonna do this. I'm gonna go print 10 okay, let's just see what that is. I always forget. This should be 0, this should be oh, yeah. spelled them both wrong. Oh my god. Car over, car over. Mmm. Okay, 1, 0. Okay, so interesting. Okay, I got the good to know. So I'm gonna say carryover equals. God, that's the problem is because I did capitalization, so I'm just gonna keep messing that up, man. Carryover plus digits of index. Okay, and then I'm gonna say digits of index. Do I return the array or do I? No, okay, I do. Ow. Hit myself. Whoops. Digits of index is going to equal. I keep putting 2. Oh my god! I always think about binary operations because of like odd, even, and whatnot, but nope. Okay, this is mod 2, and then index minus equals 1, and then basically once we reach the end, I'll say if index is equal to 1, that can only mean one thing, and that means we have a full-on carryover, so we're just going to return 1 plus digits, else we just return digits. That's the wrong answer, so... Interesting. How the hell did I get here? Oh, wait. Huh? This is a very simple problem. What am I missing right now? Ooh, crap! That's exactly what I'm missing. I need to do that. Yeah. Whoops. That will be the reason. Maybe. We'll see. Let's see if this runs. It didn't run. Disappointing. Why is that running? Disappointing. Disappointing. Why are we inserting this whiteboard? What are we? Okay, so index. Mother. So I gotta pay attention. Is that right? Okay, still not right. Really? Really? Carryover. Oh, dude, okay, still, again, here we go. My god. Temp digit. Okay, I don't know. Like, why am I being such an idiot here? This is literally just basic coding principles, and I'm just like completely flopping that. Okay, there you go. So I was overriding it on accident. Isn't that beautiful? Alright, let's see if that even runs. Such a simple problem causing me so much issues. Okay, so yeah, that was done. It's 11:03. Let's try one more. Power of excellence. We'll see. Oh oh fuck. Please tell me n is an integer. Oh god, thank fuck. Thank you. Holy hell. I mean, first things first, we can go down the path of even odds. So, I mean, we let's do a grow function and then a decay function. A def grow and then a def decay. Okay, I'm very confident that these are probably not the proper processes. I'm assuming that maybe he expects like bit manipulation. Recursion, iteration. No, yeah, I mean, no, just casual stuff. Okay, I was wondering if it was gonna use like bit manip, but nope. And I will say xval and val. And then we should do a quick statement. So ooh, I'm tired. Like either x is not 0 or n is greater than 0. So n can be greater than 0 and x can be 0. Oh, yeah, okay, I see. That makes sense. Okay, so if n is greater than 0, then we return grow of x and n, right? So, I mean, you need 3 choices. It's greater, plus, or equal. I don't have to write this as an if. I can write it as an else. So I'll say elif. If n is less than 0, then we're going to do decay. And based off of their logic, they say that it can't be 0 and 0. So, good. You don't have to worry about some funky math principles of 0 to the power of 0. You're going to get some mathematical debates. We are going to return so I'm going to say if inval is greater than or is equal to 0, return 1. Else return xval times xval. Ooh, you know, I could be wrong on this. On the division part. We'll see. I mean, we'll see. Grow of xval and val minus 1. Okay. Hopefully that makes sense. Same thing over here. If inval is equal to 0, we're done, and we will do division. And okay, let's see if a simple solution like that works. Maybe it does, maybe it doesn't. Maximum recursion depth received. Why? What are my test cases? 10, 3, -2. maximum depth is here. Here, right there. Are my eyes. Why? Print inval. If inval is equal to, let's do 400, return 1, or inval is equal to negative 400. So I don't know where we're going right now. Like, what is happening? Are we about to do a? Okay, so okay, the issue is we're asking to. What are we doing? Oh, brother. Okay. I gotta pay attention. Let's see if that fixes that issue we were running into. Okay. Mm-hmm. So that's where I had a feeling. I had a feeling the division was going to be the part that was like, you know, I had a feeling that was going to be the issue, and sadly I was correct. It looks like maybe I need to return it the other way around. Maybe I do that. Okay, that was the. There you go. Yeah, I had that wrong. I was wondering what was the catch. Oh, maximum recursion. Why? That is why. Holy. Okay, so they don't want us using recursion. Okay. Alright, okay, fine. That's fine. Just use a while loop. That's gonna be interesting. Is that gonna cause some weird issues? Okay. We'll do a new recursive approach, because it seems like that is what we need to do. Again, the division, that's going to be a little bit tricky. No. We're good. Yeah, this is fine. I think, right? Plus equals. Let's see. I don't know if that's right or not. No, it's not. Crap. So it's going to be 1 divided by equals x value. Why is that not working? Like... Why are we... What? why I just wanted to do recursion, because I feel like it was. I feel like it would have been easier in recursion. Oh, we're not printing whatsoever. What's going on? Why aren't we printing this shit? Oh, yeah. Alright, that was still slow on run. Let's see if this airs out. I mean, there's no maximum depth recursion, but who knows? Maybe it's a time complexity problem. I mean, the way I'm doing this is a O of n. Ooh, crap. If this is in O of log n, I'm gonna be honest, that's tomorrow's problem because it is late. And if it does say that, then I think I know the problem. Okay, I do remember doing something like this in my algorithms class. That's why I was like, this seems oddly familiar. Doing a power scaling. I was like, or not power, doing the power function. Because I remember doing something very similar to this in my algorithms class. I was like, I remember being O log n. Yup. So we're being silly. Okay. A little bit of DP. Ish. Yeah, I'm gonna save that till tomorrow because my eyes are freaking burning from tired, and it's 11:15. I know it was a short video. I know we only did one really stupidly simple problem, and we we completely messed the ball up on the power problem. We'll fix that tomorrow. Tonight, I gotta go to bed. So, thank you for watching, folks. I'll see y'all tomorrow.